So we get down here to example 2. It says graph of y equals 1/2 x minus 3 and determine the domain and range. And then determine whether the equation is a function, and then state whether it's discrete or continuous. Well, we've done on these types of graphs 100 times already because this is a linear equation. It is a straight line. So we will start at -3 because that's my y-intercept. Place a point there. And then my slope is 1/2, so from this point I'll go up 1 and over 2, place a point, go up 1 and over 2, place a point. Do that as many times as you want, and then you can graph a straight line through there. I don't want blue. Let's make it red. There we go. That's what I'm looking for. Throw a couple of arrowheads on each side to show it goes on forever. And that is my line. Then it says determine the domain and the range. So what do we know about lines? What is our geometric definition of a line back from geometry? So back in geometry, you learned that lines go forever. So even though my line only goes this far right here, and then I put the arrowheads, it keeps going forever and ever and ever and ever and ever. So it keeps going to the right forever and ever and ever. Keeps going to the left forever and ever and ever. So since it keeps going those directions forever and ever and ever, it's going to hit every number in existence, including all decimals, all fractions, incredibly huge numbers, and incredibly small negative numbers. So that being the case, the domain we would state is all real numbers. So that is a phrase that you're going to want to remember. You're likely to overuse this phrase, actually, but when it hits every number in existence, we say that the domain is all real numbers. What's the range? Well, this line continues upward forever and ever and ever, and it's continuing downward forever and ever and ever. So the range is also all real numbers on this particular graph. So we've stated the domain and range. Is it a function? Well, since we graphed it, we can simply just check it with the vertical line test. So can I touch the graph in 2 points at the same time? So with a vertical line. So can I do that with a vertical line? Doesn't look like I can do it there. Can I do it anywhere else? So imagine if you take a line, a vertical line, and scrape it across the graph, you're not going to touch it in 2 places at the same time. Therefore, it is a function. What type of function is it? Is it discrete or continuous? Well, it is not a series of interconnected points. It is a straight line, so it's continuous. So this is a continuous function. Here's another one. So let's answer the same questions. First off, is it a function? Yes, it is. We can draw a straight line across that, a straight vertical line, and not touch 2 points at the same time. What's the domain? Well, since it goes to the right forever and ever and ever, and it keeps moving towards the left forever and ever and ever, the domain, again, is all real numbers. Don't abbreviate that. Don't say ARN. Okay, that's not an official abbreviation. Write it out, all real numbers. And you do have to specify real numbers because there are such things as imaginary numbers that we will talk about later. The range is, since it continues upward and downward forever and ever and ever, it is also all real numbers. Is it discrete or continuous? Well, it's a smooth curve. It's not connected points, so it is continuous. I'm just going to circle that. It is continuous. Example 2 says graph y equals x squared plus 1, and then it determine the domain and range, determine whether the graph is a function, and then it says 1 to 1 and on to, and remember we're just going to ignore that, so I'll strike that out. And then state whether it is discrete or continuous. So this is not going to be a straight line because it is not in the form of y equals mx plus b because it has an exponent. There are certain graphs that you need to watch out for that will not be a straight line. Graphs that contain exponents, so these are types of graphs that would not be a line, not a line. So graphs that contains exponents on the variable, I'm specifying on the variable, is not going to be a straight line. Graphs that contain roots, like square roots, not going to be a straight line. And graphs that contain dividing by a variable. For example, if you have a graph that has you taking 2 over x, you're dividing by x, that will not be a straight line. That's going to be something else. We're going to talk about all these different types of graphs later in the year. So for right now, if you have one of those on your assignment, you're going to need to make a T-chart. And on your T-chart, I know some of you just like to do -1, 0, 1 with straight lines, and that works fine with straight lines. It doesn't work so well with curves, which is what this is going to be. So let's do 5 points. Let's do -2, -1, 0, 1, and 2. So you're going to plug each one of those in for the x in the equation x squared, y equals x squared plus 1. Get your answer for y, and then we're going to graph and see what it looks like. So what is -2 squared plus 1? Well, -2 squared is +4. 4 plus 1 is 5. So this represents the point -2, 5. So I'll go over here and graph -2, 5. And then -1 squared plus 1. Remember, -1, negative number squared will be positive, so that'll be now 1 plus 1, which equals 2. So -1, 2. 0 squared plus 1 is just 1, so that represents 0, 1. 1 squared plus 1, 1 squared is 1, 1 plus 1 is 2, so we go back here to 1, 2. And then 2 squared plus 1 will equal 5, so that represents 2, 5. So you can definitely see it is not a straight line, and we should graph it as a smooth curve. There are times where they may be straight lines that we'll talk about, but not these. With exponents, it's going to be a smooth curve. So don't be trying to connect the points like this. Okay, that kind of annoys me. So make a nice, smooth curve, and it does take a little practice. Let's see how well I do here. Not too bad. So that's what the graph looks like. Okay, so I'm going to need a little room here, so I'm going to erase this not a line part because we've got to ask a few questions. We're supposed to determine the domain and range. So the domain, it is going to continue moving slightly to the right and slightly to the left forever and ever and ever, kind of more like this actually. So since it does that, the domain is, what's our phrase? All real numbers. The range is going to be a little different because notice that the graph kind of comes down and then it gets to this point right here and then it turns back around and goes back up again. So the range is not all real numbers because it doesn't hit every number in existence. It gets down here to +1 and then turns back around and starts to rise again. So the range is going to be y, since the range is describing the y, is greater than or equal to 1 because it never gets below the 1 on the y value. So the range is not all real numbers. It's y is greater than or equal to 1. Is it a function? Does it pass the vertical line test? Yes, it is a function. It does pass the vertical line test. Is it discrete or continuous? Well, since it is a smooth curve, it will be continuous. So this is a continuous function. Okay, the last thing we're going to do is called function notation. And on function notation, it says equations that represent functions are often written in function notation. The equation y equals 5x minus 1 can be written as f of x equals 5x minus 1. And notice how I pronounced that. I pronounced this part right here as f of x. It's not f parentheses x, and it's not f times x. If you over here where it says structure, it says the symbol f of x replaces y and is read of f of x. The f is just the name of the function. It is not a variable that is multiplied by x. So f is not a function. So what you're going to do is that if they ask you to find the value of f of 6, you replace the negative 6 in for the x in the equation. So f of negative 6 would be the same thing as 5 times negative 6 minus 1, or negative 31. So down here in example 3, what we're going to do is we're going to replace the x with a 6. So we will have 2 times, and then we're going to replace the x with a 6, squared minus 8. And then we have to follow our order of operations. So we'll take 6 squared, which is 36. So I'll have 2 times 36 minus 8. And then we're supposed to, after we do the exponents, we do the multiplication. So 2 times 36 is 72 minus 8, and 72 minus 8 is 64. Let's do one more. So we have 0.5x squared minus 5x plus 3.5. And then we're supposed to find g of 2.8. Notice they call the function g this time. So we're going to replace both of the x's with the 2.8. So we'll have 0.5 times 2.8 squared minus 5 times 2.8 plus 3.5. And then we follow our order of operations. So we've got to do 2.8 squared first, and that's going to equal 7.84. And then the rest of it. And then we do our multiplication step. So 0.5 times 7.84 is 3.92. Negative 5 times 2.8 is negative 14, plus 3.5. And we finally do addition and subtraction from left to right. And when you take 3.92 minus 14 plus 3.5, you get 6.58. And that is your answer on that.